It's Harold here. So this is the first step in the Punch Up a POW project I'm currently working on. I'll tell you what I have here. I've got a breadboard. I've got a particle photon. It's currently, if you'll see the lights blinking on and off, it's currently running a test program that's just making the onboard light flash on and off. So I've got something to try with before it's all said and done. Oh, I have nothing better to do on a Friday night. This is awesome. The photon's running. It's in the board. I did a yellow test to wire the ground into the board. And before we get done today, I've got a voltage meter. I have a logic level shifter, some pins, some tools, some jumpers in case I need them, a box of big already pre-cut jumpers for the breadboard. Somehow, I don't know why, but I never seem to have the right jumper length, or at least not very often it seems. So I'm going to be making me some jumpers. I've got some solid core wire, both in black and red. Wire strippers. Don't ask me where I got these. I've had them for a long time. I've used the whole lot of them here. Back to the point where I had to replace that screw one time, so I broke the pin. But anyway, I digress. Oh, and some wire cutters. And so we're going to be hooking this up and making sure the lever shifter is doing what I believe it needs to be doing. Solder iron, the whole works. So the first thing I'm going to want to do, this is level shifters for SparkFun. It's a level converter, bidirectional. So what this does is it takes a, it's going to be hard to see if I get it out of the bag. I think the first thing needs to happen. All right. If you've never gotten one of these things before, this is pretty much how they come. So this is a level shifter. See if I can focus for us. Yeah. So this is a level shifter. Man, my nail tech would not like to see me right now. But anyway, I'll speak up. So if you look at what's on here, you'll see a few things besides the glare. You'll have something marked LV and ground. On the very opposite side, you'll see an HV and ground. That's the high voltage and the ground for the high voltage side. The other things you'll see on here, you'll see the letters HV1, HV2, HV3, and HV4, and then there's the corresponding LV1, LV2, LV3, LV4. Those are channels, they go straight across. So the idea is whatever voltage I put here on the low side will be transmitted to the high side, and it'll be proportional voltage on the high side. So if I put a full logic level 1 on one side, I'll get a full logic level 1 on the other side, but the voltage will be different. The voltage will be different. And why is the voltage different? Because this, let's go back to focusing, because the photon here that I have is a 3.3 volt base voltage board. The neopixels, which are in these through-hole cases I showed you in the first video, really want 5 volts to work. Although the pins on the photon, according to the documentation, are 5 volt tolerant, meaning I could stick 5 volts into them and it would not blow up the board. That's not the problem here. The problem is I need to get 5 volts out of them, because what happens is logic levels, these neopixels are very tight on their tolerances for the timing. And it's possible that if I'm not running 5 volts, a full 5 volts, that as I tell it to go from a low, which is about 0, to a high on 3.3 volts, and at some point I will tell it to go low again. In that time span, the voltage may not be able to rise enough to trigger a 3.3, a 5 volt logic level in a NeoPixel. So for these NeoPixels, most of these circuits these days, anything above a 2.5, 2.7 volts or so will measure a 1, and running right at 3.3, if you look at this on an oscilloscope, you'll see it takes a while to go from 0 all the way up to the 3.3 and then come back down. And because we're going up and down so quickly, it's very possible that we never see a full 3.3 voltage ever. So at the 5 volt level, since it's proportional rating, 0 to 5, because it's so much more voltage, it gets there a lot faster. And because at 2.5 volts, 2.7 volts, that's just over half of the voltage needed to make a high level versus a low. And at 3.3 volts, it's almost the whole thing. So there's some bouncing around in the circuitry. One of these days, I guess I need to get an oscilloscope and show you guys what that really looks like. So, all right. So I'll put on my eyes here. So I'm going to, because I looked on the photon, this VN can be input and output. So it'll output up to 1 amp all by itself. We're going to need a little bit more than that to power these things all in full brand. But for this test, simply pushing VN to here is all we need to do. And then when we get ready to go forward with this, what I'll do is, instead of pulling VN into this rail at the bottom over here, I will push VN in through this port through an external power supply, so I won't need this connection at all, and it'll power the whole board with plenty of current to power all the NeoPixels. To start this whole mess, we're going to do a little soldering, so we'll get that out of the way. I'm not the best soldering type guy in the world, but here's what you need to do. Get your clippers. You'll see this is a standard size hole. Amazingly, the breadboard's a standard size breadboard. And then they sell these pins by the bucket load. They're just individual pins, and you'll see how they just slide right on there, and nice and easy. See how good it opens? Just slide on there nice and easy. Problem is, you need to make sure they're nice and straight when you do this. So let's go cut a couple of these things off. Measure them right. What you do is you clip the and we're going to use the breadboard to help us solder them nice and easy. Well, that's the goal anyways. Nope, I got the wrong one. Yeah. One off. I can't count. There it goes. Alright. Knowing these things are far away, I don't need a whole lot of room. I do need a little room. And look, if you'll look also, this board is wide, just wide enough so that it goes to the first row on each one of them. So now I made this easy. So let's give just a little bit of room. Goes in there. Goes in there. Making sure I have the high voltage on this side, because that's where the VN is going to go to power the whole project. Do that. Oh, I was off by 1 row. My own eyes can't see. Alright, which one do we want? We'll go one down. I was wrong. Yeah, I'm off by 1 row. It's not as cool as I want it to be. Okay, see, it just fits right on there. I can show you here. Do a little focusing. It's right on there. What we're going to do is, see how you can press down just a little bit? We're going to press down a little bit on that. We're going to solder these things up now. All right. If you want to know how to solder these things, I'm going to show a little bit here, but if you really want to get a good lesson on how to solder them, you need to go see my buddy Electron Hacks, Jonathan. He does a whole video on that, and I think he does an excellent job. I've got a little bit of a solder here, and then what I'm going to do is I'm going to get this, make sure I got a nice hot thing. It needs to be cleaned a little bit. You want it nice and shiny. A little bit on there, and I am going to touch one side of this, go down to the side, lift up a little bit. We have a solder joint. Now I want it, this thing can get really hot, so I want to do this as quick as I can. And I want to spread out as I go. And you can go all the way down these things. I've seen people do that, but I usually go every other one, then come back. Just because that's how I do it. Now, when I'm putting this metal, when I'm not touching the solder to the tip. I'm touching it between, I'm putting the tip on the metal piece, metal pad, and the pin sticking through. And then because of when the metal heats up, the wicking action sucks it all down and makes a nice good thing. And I'm pulling up, I'm snapping up at the very end so that hopefully it gets a nice canonical shape. If you're not getting a nice canonical shape on these things, you might get a cold joint, a cold solder joint. Well, that's pretty small. Let me give me some more. Hold on. Clean it off the tip a little bit. Oh, and the other thing I like to do too is wrap a couple lines around this. Right, so it gives me and my meaty fingers a little bit of something to hold on to as I'm going and doing. Here we go, right on the edge. And yes, I got some flux running around there, but that's I think it's going to be okay. Okay. So we'll look at it. Get the focus going over here. I've got nice shiny ends. I might have got a little less. One of those I might need to put some more solder on, but I think it's okay. Not as consistent as it probably should be, but I think it's acceptable. At least for the government work I like to do. That's supposed to be a joke. Didn't really mean to offend anybody in government. So hopefully I'm done with my soldering iron. I'm gonna put the solder back up. I want to let my iron cool off. And by the way, yeah, this is from Spark Fun. I will put the I'll put the part number in the comments at some point. Man, I was chatting. I'm chatting. Can anybody actually hear me? I bet you can. All right. So now we want to wire this thing up. So I've got one ground going right here. So let's do all the grounds first. Going to make a thing, cut more than I need because I've got some fat hands. And then I'm going to need about about that much there. It's actually too much, isn't it? Yeah, it is. Yeah, that's about right. Get my bender. I know I'm cheating. Why you guys just laughing at me? Why don't you just bend them, Harold? Well, I know I'm cheating. I know. And yeah, they look like crap, but they're bent. I'm going to... And yeah, I've still got the fire going on there because it doesn't matter what I'm doing right now. I'm going to now cut the wires. Get my little pliers because I am crazy man. And find my ground hole. And of course, you know it's not going to line up, but it'll be good enough. Alright, there's one ground down. I need actually two more grounds, one for the low side and one for the ground on the other side, just so I've got a couple grounds running down both ways. So another one of those. Okay, I'll just bend them. Bend them like back. That came out nicer anyway. Ah, screw that thing. What am I doing? Again, I got some meaty fingers. On my ground. Ground. I didn't do what I wanted to do. Go. And ground goes from here. See? Okay, now I've got ground for both sides, the low side and the high side. So let's get me some red over here. And I'm going to unplug this thing out. This thing is cold. I'll take that. something here. I guess would that work? This is one of the pre-cut ones, and that's not going to work. Back in the pre-cut. That'll work. The insulation is actually sliding on these really, really small ones. I can get a couple out of this then. Alrighty. A little trim. A little trim. Yeah, I'm cutting these things off. You gotta need to be careful when you cut them off, especially around live, because they'll tend to go places on you that you don't want them to go, which is okay a lot of times, but sometimes not so much. All right, one hole there, another hole there. Okay. The high side now has high voltage on it. Now, need to that ain't gonna work. Wire. Wow. I had to give me some slightly different cutters. Yeah, where's my blue ones? This is good at making wire, I guess. Also, you may notice that when I'm doing this, I tend to grab the pieces that I'm cutting off as I cut them off, so they don't go shooting across the world and possibly shorting something out that you didn't want shorted out. A little bit more. All right, there you go. Because when these things decide to clip and go, I'm doing it either into the table, so if it is going to bounce, it's not going to bounce very far, or in a safe manner. Alrighty, a high side for the low voltage. Low voltage high side, and one more for the low voltage, so I can do something with it, and then we'll test it to make sure everything is the way I think it should be. Alrighty. So 3v3, 3v3, maybe positive side. In case you're wondering. Okay, let's see if I can try to focus it. Actually, wow, I didn't think about that. There you go. We got everything wired up there. The black's a little off kilter because I didn't because of the way I placed it, but I think that's going to be all right. So while I'm standing here and doing nothing, put on the volts thing here and see if can I zoom. No, it doesn't know how to zoom. Oh well. So let's see if things are as we believe them to be. And the way to do that is to measure. So I've got a bit of a ground going in, and I've got a bit of a red. Watching it, and you guys can see that. So on my 5 volts, you're right, I got it in the wrong place. So on my 5 volts, I don't have any yet. I'll plug it in. We've got 4.8 or thereabouts on one side. I got 3.296, basically 3.3 volts on the other side. And just to check to make sure that I've got the things where I need to go and actually plugged into where I think they need to be plugged in. Yep, we have the voltage working there. Fantastic. So really what that means is, for instance, let's make sure they work right. So if I want to get a voltage on 3B3 onto pin 1, and I'm going to put in my ground. Ground's the same number, by the way. Let me check it one more time. So I am indeed running 3.3 volts. You see it? On the other side, if I go check that, I'm running 4.8 volts. How do you know that's for sure? Watch. Ground. High. Ground. Obviously this is active high. There you go. So we're indeed working the way we think we need to work. We want to go the other way around, which we can do. I might as well show you. Ground. Voltage. Going from hot into level 1. We already knew it was running high. So, but if I ground this out, so I should go to logic level 0, I go to 0 volts. So there you go. So we indeed have a logic level shifter working just fine. And as far as things go, I'm going to wire up a couple of things, but that's it for this session. And I will fill in the comments when I actually fully really publish this thing as a project and do a little video editing. Okay, thanks guys. It's been awesome.